In this video, we're going to discuss relations. A relation is just a correspondence between two sets. We usually think of one set as the set of inputs and one set as the set of outputs, and then we match each input with at least one output. There are different ways to express a relation. We can represent it with mapping notation, a set of points, or with an equation. So first we're going to illustrate mapping notation. So for mapping notation, we just kind of draw two circles or ovals, and we put the inputs in one set, and we put the outputs in another set. And then we use arrows to designate which input is being associated with which output. So maybe the input of 0 gets mapped to an output of 0. We can map the input of 1 to the outputs -1 and 1. We can map the output of 4, the input of 4 to the outputs of 2 and -2. The inputs and outputs don't have to be numbers. So for example, our inputs could be red, orange, yellow, green, blue, purple. And our outputs could be primary and secondary. So maybe we wish to map the primary colors to the word primary, so that would be red, yellow, blue. And then we can map the secondary colors to the word secondary, so orange, green, and purple. The set of inputs for a relation is called the domain, and the set of outputs for a relation is called the range. So in our first example here, the domain is the set containing our inputs. So our inputs were 0, 1, and 4. So when we indicate a set in math, we use braces around the set, and then we list the elements of the set with commas in between. So this is the domain for this relation. And then the range would be the set of outputs. So here that was -2, -1, 0, 1, and 2. For this relation, again, the domain is the set of inputs, so our domain here is the set containing those 6 colors. And then the range will only have 2 words in it because our range was just the set of those 2 things, primary and secondary. So we've illustrated mapping notation. Another way to represent a relation is by just denoting it as a set of points. And we list the input as the first number in the ordered pair, and then we list the output as the second point. So, for example, this could designate a relation. So each input is paired with its output. So for example, the input -3 gets mapped to the output of -1. So if we had done this with mapping notation, we would have an arrow going from the number -3 in the input set over to the -1 in the output set. So our domain here, the set of inputs, is going to contain all the numbers that show up as the first coordinate in the point. So -3 is an input, -2 is an input, -1, 0, 1, and 2. And then the range, the set of outputs, would be all the second coordinates, so -1, 0, 1, 2, 3, and 4. When we write down a set of things, it doesn't matter what order we list the elements in. If we change the order, it's still the same set. So I happen to list them in numerical order here, but you could list them in a different order and it would still be indicating the same set. Also, if the same value shows up in two different points, we only have to list it once because, again, listing an element more than once doesn't change the set that we're talking about. Now, if the inputs and outputs are numbers, then writing it as ordered pairs helps us graph the relation. So let's graph this relation. I'm going to need a new slide here. So we're going to have our coordinate axis. Okay, so the inputs go on the horizontal axis and the outputs go on the vertical axis. So our smallest input was -3, so we'll need to scale it down that far. And our largest output was 2. Our smallest input was -1. And our largest output was 4. And then we can plot a point to represent each ordered pair. So for example, we had the ordered pair -3, -1. So if we find -3 on our horizontal axis and then -1 on our vertical axis, so that point would be right here. Oops. My -3 was in the way there. So we start at the origin, we go left 3 units on the horizontal axis, and then we go down 1 unit. So we end up right there where I just put that point. Okay, we also have the point -2, 0. So we start at the origin, we go left 2, and then we don't go up or down since our output was 0. Then we have the point -1, 1, the point 0, 2, 0.13, and the 0.24. So this graph represents the relation that we were just discussing. We don't connect the points because if we drew a line through these points, then we would be actually plotting more points. And for example, if we connected the points, the last 2 points that we just drew, then we would be drawing some other points that had input values between 1 and 2. So for example, we would end up with a point that had an input of 1.5, but that wasn't a point in our relation. So this graph represents that relation. So in addition to mapping notation and listing a set of points, we can also just use an equation to represent a relation. And we usually use x as the independent variable, which is for the inputs, and we usually use y as the dependent variable, which is for the outputs. Of course, we don't have to always use x and y, but a lot of times that's what is done. So usually, if we're given an equation, we would just choose some inputs, input them into the equation for x, and then find the corresponding output value. And then we can actually use that to graph the relation. So for example, here's an example of a relation. So if we wanted to graph this, we could choose some inputs. And then we could substitute them into the equation to find the y value. So for example, if x is -2, then calculating this value will tell us what y is. So squaring -2 means we're doing -2 times -2. So a negative times a negative actually gives us a positive there. So this value, for example, would be 8. And then similarly, we could substitute in each of the other x values. So if we substitute -1 in, for x, then we have -1 squared, which is 1, plus 2, so 3. So I'll spare you the details here. So these would be the corresponding y values. Again, we would just keep substituting those x values in, see what the y value is, and now we have some points that we can plot to graph this relation. So I'm going to erase my work here. So here's our axes, there's our x-axis, there's our y-axis. And then we can plot the points that we just found. So I need to go up to 8 here. 1, 2, 3, 4, 5, 6, 7, 8. All right. So we had the point -2, 8. So we're right here. -1, 3. So 1 left, 3 up from the origin. 0, 0 is the origin because we don't go left or right at all, so we just stay there. 1, -1, so 1 unit right and 1 unit down. 2, 0, so 2 units right, 0 units up. And then 3, 3, so 3 units right, 3 units up. Now in this case, our relation was given by an equation. So when our relation was given by a set of points, those were the only points in the relation. But here, the relation was given by an equation. So it's implied then that you could substitute any value in for x as long as you were then actually able to get a y value from that. So these 5, 6 points that we just plotted aren't the only points on this graph. This pattern would keep going. We could keep choosing larger and larger x values, and so it'll go to the right, and we could keep choosing smaller and smaller x values, so it'll go to the left. And in theory, we could have chosen numbers between integers. So for example, we could have chosen an x value of 1/2, or 0.7, or 2.5. So in this case, we do combine these, and then to show that the pattern would keep going, we just put arrows on the ends of the graph.